Hi.
We're gonna wait like 2 or 3 more minutes for some more people to show up. In the meantime, if you guys want to get a Google Colab open, that'd be great.
I missed last class, so what am I supposed to do?
I got it. So it's not a big deal if you missed last class because we're gonna go over a lot of what we did last class because a lot of people found it pretty confusing. So you're not in like a bad shape. You're fine.
Okay, thanks.
Okay. So hello everyone. Today we will go ahead and get started. So today's I like the goal for today is we're just gonna go over a lot of the same concepts we went over last time. And this time, instead of you guys just watching us, we want you guys to follow along and actually try to code it yourself. So if everyone can open up a Google Colab file and have that ready, you're actually gonna need two because we're gonna do two things today. But you can start with one for now. And we're just gonna go through and we're gonna code a really basic linear regression project, a lot simpler than last week's, and then a very basic neural network in literally 10 lines of code, just so all of you guys can do it. You don't need to learn, you don't have to like understand all the background math. We're just gonna go a lot into the actual coding so you guys understand how it works in code. So why don't we get started on linear regression with Viraj?
Yeah, let me just screen share it. Can you turn screen sharing on, Ayaan?
Yeah, one sec. Okay, I think
Are we
good now.
supposed to publish these codes on GitHub?
Yeah, so yeah, you can just push that to GitHub whenever you want, whenever you're done. If you need help, just message me on Slack and I can help you out because there's no chat in this for some reason.
Okay, I got it now. Okay, assuming all you can see my screen. And so like Ayaan said, we're gonna do one more linear regression project, and ideally you guys should be following along in your Colab notebook that you will publish to GitHub. And
So we'd like to see
so-
everyone publish the notebook by the end of this, like by the end of today, just so we can see that who's done what.
Yeah, exactly. And so today we're going to use a linear regression model to predict the advertising value of a product based on the sales value. So you have a product, you know it's worth a certain amount of money, and you want to see how much you should promote it, how much money you should spend on advertising it. And just in general,
should we make a new project,
Yeah.
or should we just add to the original one?
You can make a new, like completely new notebook, just because you don't have to code the words. You just have to code like the actual like Python.
Yeah, just the Python.
Okay.
And just so everyone knows, this notebook is in our lesson material. So if you're confused at the end, you can go and look at it. And so in general, across machine learning and also specifically for linear regression, there are these 5 kind of basic steps. First, you get a bunch of data that you want to train your model with. And then you, depending on the data, you have to manipulate it a little bit. So you have to process it. And then after that, you're going to train your model. And your 4th step will be testing how well does your model actually work? Does it work well? Or is it kind of iffy or what? And then your 5th step will just be actually using it, like using it to make predictions on something. And we're going to go through all of these. And so our first step will, as I said, be data collection. And before doing anything in a Python project, you always want to import your libraries that you're going to use. And we're going to import for now NumPy, Pandas, and Matplot. And I'm assuming all of you took the Python class or have some base knowledge of Python. So you guys should know what these libraries do. And
Yeah, and we went over them last week also, so it's a lot of the same stuff as last week.
Yeah, exactly. And so now that we have our libraries, also everyone make sure to copy all this down, as we said. Whenever you see any code, these brackets here, that represents code, and you should just copy that down. And
if you guys have any questions, just ask.
Yeah, and please unmute because again, we don't have a chat or anything.
Yeah, there's no chat today for some reason, so.
I don't know what those functions do.
Okay, so just in general, NumPy basically lets you use math with Python, so you can add stuff, put it into arrays, that kind of thing. Pandas will let you take a data set and change it around and manipulate it. And that's what we're going to do a lot of today with our second section of data processing. And Matplot, it basically lets you visualize it and make graphs with Python. That's kind of a basic overview of what they do. And obviously there's a lot more we can go in depth, but just for today, that's all you need to know. And so once you have these libraries imported, you can use their functions, and that's what we're going to do right here. So I'm going to copy this link into the Slack because obviously you guys shouldn't have to copy that. Check the AI/ML channel.
Just quickly show them how to get it from the GitHub.
Oh yeah, sure. So you go to GitHub, SIP. So I'm in my lesson materials repo. This is the repo that I'm using. You can copy the file into your own repo. And I just
for now, you can use the link that Viraj is giving you.
Yeah. So I imported the CSV here. A CSV, as we explained in 2 classes ago, I believe, is just a spreadsheet of all your information. And that's what the basic spreadsheet looks like. But if you strip away all of this, all the lines and everything, that you do that by clicking the raw button here. And when you get that, you just get what it looks like with no overlaying processing. So this is just the general numbers, and this is what we're using. So from here, we're basically telling, right here, we're telling our code that we want to take the data here and put it into Pandas and allow Pandas to make a data frame from it. Does that make sense?
It
Okay,
basically just takes the CSV and puts it in code.
Yeah. So right here, that's what you're doing. You're taking the data I just showed you, and you're putting it into your code, and you're initializing it through a variable we're going to call df for data frame. And so from there, we just want to make sure that our data, it actually looks like how we expected it to look, that it's not anything weird. And we do that by using the head function. And the head function, it basically, the default is it lets you view the top 5 rows of your data set. And so we're just going to print that. And if you can see right here, when we printed it, it came out looking like that. It looks like a normal data frame, right? And it matches exactly with these first 5 rows up here. So we know that we were able to successfully import our CSV as a Python database. And that's actually all our data collection. That one CSV is all the data that we'll need. And so we're actually done with that section for now. Just to make sure everyone got this is all the code that you need right now.
Quick question. So do we have to like run the df and then the print df head, or do we?
Yeah,
You need to run it.
You just highlight all of it and then come up here runtime and click run selection.
Okay.
Or you can just press the triangle on the left.
Yeah, or that.
Will this code be posted in GitHub?
It's already posted, but
So,
you guys should.
yeah, if you want to follow
definitely
along
do
on your own
so.
computer, you can pull it up. It's in the lesson materials repository.
Yeah. Any more questions, or can I move on?
Yeah.
Okay. So now that we have the data, we want to process it and make it compatible with our model, because if you just input this into our model, it's not going to work because that's not what our model takes as an input. And so we have to change it around a little bit. And the first thing we're going to do is give our columns the titles to make it easier to use them. And we're going to call our first column sales and our second column advertising. And we do that right here with df.columns. And just to make sure that we actually were able to rename it, we use the head function. And as I said a few minutes ago, the head function just lets you see the first 5 columns. And right here, we're able to see that we were able to rename the columns. And the first one is called sales and the second one's called advertising. That's pretty simple. And next, we want to isolate our sales value. So everything in the sales column, this column right here, we want to take that and give it its own variable so we can manipulate that specific column, right? And we do that just by using x equals df sales.values. And that just says that everything in x is, all the values in the sale column are now part of the value x. And we do the same thing with y. So we just call y equals advertising.values. And so all the values in the advertising column are now in the variable y. And so at this point, we've isolated our the data sets, the columns of our data set, and we give them their own variable, which will be helpful during training. But we still didn't change the actual inputs to make them compatible with our model. And so that's what we're going to do next. And machine learning model, a lot of machine learning models, but specifically for today, linear regression, we'll need an input of a 2D array. And if you haven't taken algebra, a 2D array is basically when you have an array of arrays. So you have arrays inside arrays. And so we just need to basically convert all these numbers in the column into 2D arrays. And we do that using the NumPy reshape method. If you remember, NumPy gives you access to a whole lot of mathematical functions. And so using NumPy reshape, we're able to morph the regular array into a 2D array. And you don't have to worry too much about the -1, but just so you know, -1 is kind of like a placeholder. It will basically defer to the other number here, 1. And 1 basically says that I just want one row of numbers. And so we're going to do that for x and y. We're going to say x gets reshaped to a 2D array and y gets reshaped to a 2D array. And just to show you guys what that would look like, if we print x, we end up looking like that. So you can see it's just a giant array of all these mini arrays in here. And at this point, these variables are able to be inputted into our model. And so we just have one last step. If you guys remember from last time, we always need to split our data into a training set and a testing set. And we do that using scikit-learn and import test train split. And using this function here, we basically split the data set into 1/3 is the testing size and the rest of the 2/3 is the training size. And using that, we're able to use the training data set to train our model and the testing data set to test our model. And that's actually all the data processing that we need to do. Any questions about that section? Okay, cool. And so now we have our data set, which is great. And so now we can actually begin the initial process of training our model. And as I mentioned a lot before, scikit-learn is the best way to do that. And so from scikit-learn, we're going to import linear regression because we know linear regression is the function that we want to use. And so just to take all the capabilities of linear regression, we initialize that in a variable we're going to call lm. And so now we have literally everything that we need to train our model. We have the data set that we need properly configured to be an input for our model, and we have our model initialized right here. And so training the model itself is actually just one line of code. And you can see that one line of code right here, lm.fit, and then we take our training data and our for x and y, and we input that. And this line is really simple. If you remember all the math stuff from week 2, we're basically able to condense that all into one line of code. And basically what this line does is it comes up with a starting hypothesis, and then using the cost function and gradient descent and that kind of stuff we talked about from week 2, it'll fit the line better and better to the training data and try to decrease the error margin. And from there, now that we've trained our model, we should visualize it and just see for ourselves how well it fits. And so we do that using the matplot structure. And matplot, as I mentioned earlier, is just a way to graph our function. And you guys don't need to worry about the actual code because the code is not very complicated. It just basically is different parts of forming a graph. But you guys should definitely copy it down, but don't worry about what it actually does because it's pretty straightforward. And so you can see right here that the blue line represents what we built, our machine learning model that we just built. And the red dots represent the training data that we try and minimize the error with. You can see that it's kind of spread out. It's all over the place right now, the training data, but our line has minimized the error to the point where it goes through relatively all the data. It touches a few, and it's relatively close to almost everything. And so at this point, we've trained our model. We have a working model, right? But we don't know exactly how accurate it is, right? And so what we want to do is we're going to use the training part of our data to basically assess how well our model is working. And what we're going to do for that is we're going to use we're going to run this line of code, which is y predict equals regressor dot predict and then x test, right? And then, oh, sorry, this should be lm, my bad. And basically what this does is it says that using the x test variable, I want to predict a bunch of y variables. So, and this will basically let us see how well our model can accurately map data. And so now that we ran this function on all our testing data, we should just see how well it fits. And you can see that with all these types of, all this data that it hasn't seen before, it's able to relatively go through them well. It goes through a few data points and it's generally in the middle of everything. And so we can be reasonably happy with that. And at this point, we've basically trained our model and we assessed how well it kind of fits visually. Ayaan will show you how we can do that numerically, but just visually, this is how we do it. Do you guys have any questions about it? Okay. And now that our model is done, we can actually put it to use and give it an application. And so we can just, the first way we can do that is just by predicting values of items in our data set. And we can just do that using this line right here. But a better way to apply it is giving it data it hasn't seen before and actually applying it to something someone might use someday. And so right here, we can just input any number that is basically cost data, and it'll give us how much we would spend on advertising that. So if you have a $28 product, you should spend about $34 to advertise it. And basically in all our code, that's basically it. That's everything we have. Do you guys
If
have
you
any
guys
questions?
missed any part of it, just ask and Raj can scroll back up and show you.
Yeah. Okay. If you guys have any questions, tell me in the Slack. But for now, we can move on to neural networks.
Okay. Let me go ahead and screen share them. 1 second. Okay, so I think you guys can see this. Basically, we're just going to build a very basic neural network, and we talked about this in week 2 and week 3. Basically, it's just a machine learning model that is based off the way that our brains work, and basically it has different layers. It has an input layer, a hidden layer, which is usually in the middle, and then an output layer, and the output is what like our predictions are, right? So basically today we're going to build a neural network in essentially 10 lines of code. So everyone should follow along. If you guys want, you can just add it to the bottom of your your Colab file that you already have, or you can make a new one. It's up to you. But everyone should be following along since it's really easy today. So basically, we're going to go over how to build our model, how to initialize it, how to train it, and then how to validate its performance. So just start off by importing these functions. Basically, from NumPy, we're going to import load.txt, which just allows us to open our data set. And then from keras.models, you guys should import sequential. And if you guys remember, sequential is basically how we will create the layers for our model. And the layers in our model are called sequential models because they go in like order 1, 2, 3. And then we have from keras, we're going to import dense, which is basically a type of layer also. And then lastly, we want to import matplotlib, which we saw with Viraj. It's the same thing. It's just we want to be able to visualize our performance. So I assume you guys got those 4. It's pretty fast to type. So, and you can just run it when you're ready. So let's just run this. Whoops. Oh yeah. So it'll say it's done.
Just a moment.
Okay. Anyway, so let's talk about the data set that we're going to use. What you guys should do is go into the lesson materials repository, scroll down to the Pima Indians Diabetes CSV, and then go ahead and press raw right here. Do you guys see on my screen where it says raw? And then once you get that, copy this link that I'll drop in the Slack real quick. And you guys can also just copy it from the Slack or copy it, just like get it from how I showed you. And then you should just have that ready because we'll code it.
What are we making this model for?
Yeah, I'm going to explain that right now. So basically, we're going to use this data set, which is about the Pima Indian tribe. And it talks about like which people in the tribe have got diabetes. So it has patient medical records from the Pima Indians, whether they had onset of diabetes within the last 5 years, which just means like, did they have diabetes recently? And diabetes is a disease, and this is like one real application you can use neural networks for. So as such, it's a binary classification, which just means it's either they have diabetes or they don't have a diabetes. And then all of the input variables that describe each patient are numerical. And this makes it really easy to use with neural networks, as neural networks need a numerical input and an output value, right? And so basically we have to do very basic data processing. We don't have to do anything crazy for that. So we made it very easy for you guys. So let me quickly show you guys how the data set looks. So right here, we can see that this is basically the, so let me explain what each of these are. So, so we're gonna load it using the, okay, in the meantime, while you guys are listening to me, you guys can just copy this code and I'll explain what it does in a second, but just write it down for now. So basically there's 8 input variables and 1 output variable, which is just, do they have diabetes or not? And we will be building a model to map rows of input variables, X, to an output variable, which we often summarize as Y equals F of X, which is just a function, right? And the variables can be summarized basically, for the input X, we have just basic stuff about like their blood pressure, like tricep skin fold thickness, body mass index, BMI, diabetes pedigree function, and their age, stuff like that. You don't have to worry too much about what each does. We just know that we have medical records. And then the output variables, which are Y, right? So Y is equal to F of X, which means that we're in our function, which is our model, we're giving it the input variables of X, and we're getting an output, which is the prediction of either 0 or 1. And 1 means they have diabetes, 0 means they don't have diabetes. So we're going to open the CSV file, and then it's going to be stored in a 2D array, which basically is an array of arrays. And the first dimension is going to be, it's going to be rows and columns, right? And we split the array into 2 arrays by selecting subsets of columns using the standard NumPy splice operator, which is just the colon. And we can select the first 8 columns from index 0 to 7, because as you guys know in coding, like indexes start at 0, not 1. And then we're going to splice it. And basically the 9th variable is our output column. So if you guys were following along, if you guys coded this, you guys have the data set, right? You guys would just, you can just load txt and then you do parentheses, quotations, add that link, and then put delimiter, and it is equal to a comma, because that just tells you like where to split it. And then we're going to split our inputs into X and Y. X is, so we're going to do data set, which is our data set, and we're going to splice it at the first 8 columns, and then the Y is just going to be the 8th column. So I assume you guys all copied that. So now we're going to like build our model, and this is like the fun part. So this is like the bulk of our project as well. We're going to be using this Kara sequential model, which just like last time is going to have 3 layers, and their input dimensions are 8, since we have 8 different factors which contribute to someone having diabetes or not. And with those 8 factors, we're going to determine if they get diabetes. So it's really simple. Let's just start with model. So we're defining our model. We're just going to create the model. It's going to be sequential and then parentheses, because it's like we're calling a class basically. And then we're going to add layers to it. So you just do model.add, and then we add the type of layer, which is called dense. And then inside of that, we give it a couple parameters. And while you guys copy this, I'll explain what each does. So 12 is just how many nodes we want. The input dimension is 8, since we have 8 inputs, right? 8 different factors, such as age, they're like other things like that. And then we're going to use the activation function. And the activation function is basically what is a transformation that we do to the data. So we take the number in and we do a little calculation with it, and then we pass it on to the next layer and we do another calculation. You don't have to understand how the math works because it's pretty complex. You do need to know a lot of math, but all you have to know is that it's just a function. It's just any sort of mathematical equation. And then we're going to add another layer, which is called another dense layer. And we have 8 nodes, and the activation function is, again, ReLU. Just copy it as it is. And then lastly, we're going to have, do you guys need me to zoom in on this? Is this a little? Or someone in the Slack said, yeah, I think you're fine. I don't think you have an issue if that didn't show TensorFlow backend. But do you guys need me to zoom in? Is this a little hard to see?
Yeah.
Oh, okay, sorry. Did you guys? Okay, I'm gonna. Okay, let me go one more in. Okay, so you guys all got this part, right? I mean, you guys got the link from either the Slack or I showed you guys how to get it. Does anyone need help on how to get this link?
No.
Okay, cool. And then just copy these. This is just for splicing our data. And again, X is our inputs, Y is our outputs. And then when we run this, oh, whoops. I guess didn't. Oh, I put an extra H right here. Whoops. Okay. It should just be one H, and then it'll just work, right? And then we know it worked because it gives us the parentheses. And then, so now we defined our model. I think you guys all copied it. It's only 4 lines. So when we run it, it worked, right? Because like it worked. So then we can just do, we can do model.summary to get what our model looks like. And this shows our model, right? So basically we have, it's a very small, really basic model. We just have, we only have 221 different connections between the nodes, which means it's very easy to like learn about. So you guys can copy this. You don't need this line, but this just shows us what our model looks like. Then what we can do is we will compile our Keras model. And this just means like we're gonna actually give it the things it needs, right? So for every model, you need a couple things. Basically, the 2 things that we're gonna give here is we're gonna give it a loss function, which is basically, the loss function basically calculates the error for our model. So what it does is it looks at so it has an input, right? Which has like the 8 factors. And then we have a label for it. And that label is either 1 or 0. Did they have diabetes or not? And then what we do is the model predicts what it was, and it will give a decimal between 0 and 1. And then we subtract that label and we find the difference and we find that error. And based on that error, our loss function can actually figure out how to adjust the weights in the model to reduce that error. And then the optimizer we're going to use is Atom. And again, the optimizer does all your calculations for you. So you don't have to learn about the math in the back end. You just have to learn that the optimizer is Atom. And then for metrics, it's just going to tell us like what like metrics to show. And like we see that we get accuracy here. So when we run this, it'll compile and it's good to go. Did everyone get that?
Yeah.
Okay, cool. So now we're actually going to train the model. And before I run it, let me explain what it does. So basically, we're fitting the model to the data set, which means that we're taking our model and we're giving it data, and it's going to learn from that data, and it's going to be able to predict future data, future things about this data. So what we're doing is we're just going to call it training, and then it's going to equal model, right? And then dot fit. Dot fit means you're fitting it, you're training it. That's what it means. And then we have to give it a couple parameters. We have to give it a couple things so it can run. First, we have to give it the X, which is just basically our inputs, which we coded up here, right here. We coded up here. And then we give the Y, which again is the labels, which the labels tell us what each person, do they have diabetes or not? And based on the factors that they had, we learned which factors are important, like what number values for each factors are important to whether someone has diabetes or not. Batch size is just how many pieces of data do you want to give at a time. 10 is good for now. And then verbose is just like a vocabulary word. It just means that how much is the model telling us. So, and oh, sorry, I skipped epochs. And epochs basically is a single epoch basically means one run through of all the data. So basically, once we give the model the entire CSV file, all of the data in the file, that's one epoch. And we want to give it multiple times so it can see it multiple times and learn from it many different times. So we're just going to go for 150. And once that goes, we can press this and it's going to start training. And we see it's going really, really fast, right? So it's giving us updates and we see that it's running really, really fast, right? So it's about like 3 a second, I would say. And then, so it'll finish in like, that was like what, 10, 15 seconds. Most machine learning models don't train this fast, especially when you have more data and like a bigger model, but this is what you should get. Did everyone run this? Did this work for everyone?
Can you go to line 4?
Yeah, right here. This one or this one?
Yeah.
Okay, yeah. Do you want me to explain what these do again?
Yeah.
Okay, so basically, the sequential is just the type of model that we want. And then that's just like a type of model that you should know we're going to use. And it's part of Keras. Then you're going to do model.add, which is basically we're adding the layers, and we're using a dense layer. And the first layer is the input layer, and input dim means the input dimensions, and we're giving it 8 because our data set has 8 factors for each person. And then we're giving the activation function of ReLU, which is just in like a math calculation. You don't have to worry about it. Then we add another layer, which has 8 nodes, which is an activation function of ReLU. And then the output layer, which has just 1 node, 0 or 1, and it has an activation of sigmoid. Does that make sense?
Yeah.
Cool. And
Can
then,
you explain?
Yeah, go ahead. Sorry.
Can you explain the data again?
Yeah, sure. So basically, the goal is to basically look at someone's like a person's qualities, and so the goal is basically to predict if someone is going to get diabetes or not, based in this Indian tribe. So what we have is we have a couple different input values, such as we have like these like I don't really know what these mean, to be honest, but like they're like medical records, right? And then we have like tricep fold thickness, 2 hour like serum insulin, like age, and then the output variable, which is Y, is just 0 or 1, right? And 0 means they had diabetes, or they didn't have diabetes, and 1 means they did have diabetes. Okay, does that clear it up? Do you have any other questions about what we're trying to do?
That's fine.
Okay, cool. And then here, these 2 lines are pretty important because here we're giving it a loss function and we're giving it an optimizer. And the loss function is basically like a mathematical equation that we want to get the lowest value for, which means that, and a lower value means that we have a better model. And then the optimizer is called Atom. And Atom is basically just, it's an optimizer. It's like a mathematical equation, basically. You don't have to worry about it. It's pretty advanced. And then metrics is just like what metrics do we want? We just want accuracy. And then for training, so everyone got this line in? Okay. And then we want to run training, right? And then so you guys, once you run this, you'll see that you got all these things right here. And then it gives you an accuracy of like 677, 67, etc., right? And so with that, we train our model. So now let's like look at our model and let's see how it like the progress of our model. So what we can do is we can see how the accuracy of our model increased over training. And then this is the accuracy, right? So we can do basically you don't have to write this print function actually. But PLT is just for plotting. It's just plt.plot, and we give it the training.history. .history shows us the actual like how did our model train, right? And then we're going to choose the accuracy metric because that's the metric that we wanted. Then we do plt.title, which is model. We can just give it a title. It's just like when you create a graph. Y label, which is this label right here, accuracy. X label, epochs, and epochs is every iteration of data. And then we just do .show to show it. And then when we run that, we see that our model, this is the increase in accuracy over time. So we see that it's gradually increasing. There are ups and downs, but the overall trend shows that it's gotten pretty good, and it got to around 75 to 80%, which is not great, but it's good. Did everyone get that down?
Accuracy, Shui.
All right, did everyone get that down? Okay, cool. So now let's look at the loss, which is basically, it's the same thing. We're just going to do plot the training history and then loss. And the loss is the thing we're trying to minimize, the number we're trying to minimize, the difference between the label and the prediction. And this is what it looks like. You guys don't have to copy this. It's not a big deal. And so now let's evaluate our model. So basically we want to see how does our model perform on data it's never seen before. So what we can do is we can do underscore, because like when you do model.evaluate, it gives 2 outputs. We don't really need this. We just want the accuracy. So what we can do is we'll do to underscore comma accuracy, and that's equal to model.evaluate, give it the X inputs and the Y outputs. And then this will just give us the accuracy, which you have to do these weird things because it doesn't give the accuracy like a very like nice number. Like if I showed you guys right here, it's a little weird. It's like Oh, actually, yeah, it works. So what we can just do is we can just do, oh, sorry. This is for adding variables, right? So what we can just do is if we just do this times 100, we see that our accuracy is about 76.3. And so for those of you that trained it, you probably got a different accuracy than me. And the reason that you got a different accuracy is because neural networks are stochastic, which just means that they vary and they have lots of different factors, right? Which means that the same algorithm on the same data can train a different model with different skills each time. And this is not a bug, it's a feature. And then this model won't perform that well. It only got to 80% because the architecture and the amount of layers that we have is not that much, which means that it's not doing very well. However, it's a very simple architecture, meaning it's a good place to start and learn from. Did everyone get this down? I can go over like any parts that you guys didn't get. It's just like we have a good amount of time, so I think we should ask questions about any line of code that you guys didn't copy down or didn't understand, or any part of this that you guys want to learn more about.
What does the underscore comma mean?
Oh yeah, so basically, if I could show you right here. So, if we do print model.evaluate, right? So basically, we get two numbers, right? And the first number is the loss of our model, and the second one is the accuracy. And since we don't really want to look at the loss, it's not that cool to look at. It doesn't really tell us much about the model. The accuracy is a better number, obviously. We just do underscore just because we don't really need it. But if we didn't have it, but since it gives two outputs, we just don't want it. That's why we put an underscore. Does that make sense?
Okay.
Yeah. So I guess, did everyone understand like any questions about like training itself? Because this training, does anyone have any questions about what happened here?
Yeah, is there any difference between training numerical models and training image models?
Yeah, so there is a difference for numerical models. You don't have to do any processing because the numbers are just like they're numerical, right? And a machine learning model and a neural network, they take in numbers, which means that you don't have to like do any weird data processing for it. But for an image, you have to actually, and we'll do that probably next week. For images, you actually have to convert them into numbers, like numerical values. So you would like do an RGB, right? In like red value, blue value, green value, and then you would get numbers and you get arrays, and then you put that into a model, and then you convert that back out to like images. Yeah. So, any other questions about any of this? It was just like pretty short. It was only about 10 lines, I think, or 10 lines of real code because you don't have to put the comments or anything, and like the print functions. So, does anyone have any more questions about like training, about the layers, about the model itself? Anything you guys didn't understand?
What's cat dog what's CNN detection?
Oh yeah, so that was what was on the thing for today, but we just wanted to like slow it down a little bit. That a CNN is a different type of neural network. It's called a convolutional neural network, and that's different. It's a little more advanced. We might go over it next class depending on what we think is like how we're progressing. But CNNs are usually used for images. So when you ask about images, that's what they're usually used for.
I just have a general question for all of you. We're thinking of having you guys build your own basic machine learning model, maybe during our last class or maybe starting next time. How many of you think you're comfortable with doing some sort of basic machine learning model? Like it can be linear regression, something simpler, something like a neural network. Could you guys just raise your hand in the chat?
I don't know if I can do that. Let me check. I can do a poll.
Sure.
Okay, never mind. Well, if you guys want to quickly text in the Slack, is there anything else you guys want to go over for these, like, or even the linear regression notebook. Does anyone want to look at that again?
Can you scroll down to the model loss graph?
Yeah, sure. Yeah. So it's really similar. It's just that instead of loss, we want accurate. Instead of accuracy, we want loss. And history again just shows us like over the course of training, how did it look?
Where are the recordings? Because there's only week 1.
Yeah. We asked Shivam. He's good. We'll get them up soon. Sorry about that.
Oh, I thought they were up already, but
No, yeah, it's
it's
just
not.
week 1 still. I guess. If you guys want to speak up, like if you guys were able to train it, what did you guys get as your accuracy? I want to see like how different they were. So anyone who trained it, what did you guys get as the accuracy?
I got 77.34.
Yeah, okay, that sounds right. That's pretty close. Anyone
I
else?
trained for 700 epochs, and I got an accuracy of 83.85.
So that's pretty good. So if you guys want to train for more epochs, you'll get a lot better value. So let's say we just did 300 epochs here. It'll take a second, like it'll probably take like 20 seconds, but you'll get a lot better metrics because think about it this way: the more times the model sees the data, the better it's gonna get, right? Because like if you show like think about like if you're teaching someone, right, like and you show them the same thing like so many times, it's much easier for them to learn. It's the same thing for a model, right? You give it the data like a lot of times, it's gonna learn a lot better. So it's almost done. But we can see that our accuracy for 300 epochs got up to 80%. So if we went over here and we plotted it, we see that our accuracy got a little higher. And then if we came down here, we evaluated it, we see that we got 80%.
Is there a max number? Because I'm trying to run 1,000 right now. Is that?
So there's no max technically, but like if you run a lot, it's gonna like take a really long time, and it's like obviously for something like this, like a really basic model like this, you can run it for a lot of epochs because it's like super basic. You don't have to do many calculations. But for a model that has like 15, 18 layers, right, it's a lot harder because there's so many different layers and there's so many different calculations. And like it also depends on the data set size. If the data set is really big, it takes longer to do the calculations, right?
At some point, your model is going to converge, and it's basically going to flatten out. And however many more epochs you run, you're not going to get a better result or anything.
Because it's seen it so many times that it doesn't really matter how many more times it sees it because it's already good. And like you're like the best models out there usually get like around 98%, but those are really advanced, like really good architectures, and that really just comes down to how you build your model.
I have a question about saving a file to GitHub.
Yeah, go ahead.
So, how do you make it so that if you edit it, then it'll also be edited in your GitHub repository?
Yeah, so every time you edit it, you have to push it again to the repository. So let me quickly show you guys how to do that. So what you guys can do is in your Colab notebook, you can do file, save a copy in GitHub. So when we do that, it's going to ask for authorization. And then, so when it loads, we see that you can choose the repository. So you guys should choose your repository, whatever your repository is. And then you give it a name, right? And then you can give it a commit message. So we'll say that week 4 class. And then we'll just do include a link to Collaboratory, which allows you to open it in Collaboratory a lot easier. And then you can press OK. And then it'll create a copy. And then it will add to this repo. Don't add to the lesson materials, please, because that's like for us. Add to your own personal repo. Was anyone able to do that through this? Was there any issues with that? No, is anyone able to get that working?
Yeah, I got it.
Okay, cool. Yeah, so let me just quickly see how many of you guys were able to add in your stuff. Okay, great. So yeah, why don't you guys add all your code to the repository right now? And in the meantime, does anyone want to see the linear regression notebook again? I can quickly show you guys. Does anyone want to see the linear regression one?
Wait, so then how do you make it so that you can edit it? I mean, that it's edited on GitHub after you edit in.
Yeah, so every time you finish coding in Collaboratory, you just have to do file and then, you just do file and just save a copy in GitHub. It's just
automatically update. You have to
Yeah.
save a copy every time you change something.
Yeah. Any other questions? Because we do have some time left. I guess do you guys want a quick refresher on like the background theory, because we didn't really go over that in a little bit. Anyone have any more questions? I guess we could end a little early today. If you guys need help with the code right now, it would be a great time because we're all here. So
Just a quick
was everyone? Yeah, go ahead.
When will this be posted? Like,
It's already posted. If you just go to the lesson materials repository.
no,
down.
I'm talking about the video. Like,
We're not in charge
Oh,
of the video. Shivam is, but we're gonna try and get him to put it on the tiny URL.
yeah,
Yeah.
because the last two classes haven't been posted yet.
Yeah, that's kind of annoying. We'll talk to him. Does anyone have any questions about any of the code that we went over to? Because I can help you guys with any errors that you're getting right now. I think we do have some time, so if everyone wants to try to code it right now themselves, it really is 10, 15 lines. So.
Does anyone have anything in machine learning they may have looked up on their own or something that they want to learn more about? Like something you guys are really interested in that you want to cover in a future class?
Can we learn how to do images?
What was that?
Can we learn how to do images?
What part do you mean specifically? Like making images and analyzing images?
No,
And anything like
detecting
that?
objects object detection.
Oh, I see. Yeah, we could go a little bit into that next time.
I think next class, what we'll probably do is we'll probably do a machine learning algorithm, and it's going to be on with cats and dogs images. So, yeah, we can go over that. Anything else before? I guess we could end a little early if no one has any other questions. Okay, great. I guess we'll end class now since everyone. I hope everyone was able to follow along a lot better today. We went a lot slower, so. And if you have any questions, just shoot a message in the Slack. That'll be great. All right. Bye, everyone.
Thank you. Bye-bye.
No problem.
Bye.
Thank you.